All right, it's 10:10. Let's get started. Okay, well, hello everyone. My name is Mallika Nocco. I am a new Assistant Cooperative Extension Specialist in Soil Plant Water Relations and Irrigation. Oh, hold on, let me start my video. All right, there. Hello, can everyone see me and my slides? Okay.
Looks great.
Okay, good. So my name is Mallika Nocco, and yeah, I'm an Assistant Cooperative Extension Specialist in Soil Plant Water Relations and Irrigation Management located at UC Davis. For those who are joining from across the world, so basically what this means is I have a research lab. I advise graduate students, but I do both research work and extension work. And I really have this irrigation focus. My lab and my graduate student, Logan Ebert, is joining me today. We are a part of the Conservation Irrigation Lab. You can check out our website at irrigationlab.com. And this, I want to give a lot of credit to Dr. Derek Young, who couldn't join us, but really developed this workshop with me and developed some of the tools that we are going to talk about a little bit. The scripting tools specifically. Derek has done a ton of work on making, providing some open source scripting tools for Metashape. I bring up this, my background a little bit just because it's kind of informing where I'm coming from and where I suspect maybe many of all of you are coming from, which is, everyone has a different background when they get to this point. And those who are thinking about, photogrammetry, your entry point might be different. So for me, my entry point was coming from this water place. And I'm going to talk more about that if anyone wants to come to the crop water stress workshop tomorrow. But I, think about crop water, I think about irrigation, and I really got into mapping of evapotranspiration. And I was using aerial imagery with an airplane, and that was great. But anybody who, has done that type of imagery, you get into problems if you have clouds. And I was in the Midwest when I was starting that work, though I'm in California now, and there are clouds all day, every day. And so I remember on the chat a couple of days ago, someone had said, why would we use drones if satellites are going to be higher and higher resolution? And for me, I planned to use a combination of aerial imagery and satellites. And the reason that I got really excited about using drone imagery was this cloud problem, and then being able to just flexibly map evapotranspiration. So I didn't really know much about what photogrammetry really was until about 2 years ago, when I was trying to understand how to process the data that I was collecting in order to create higher and higher resolution maps of evapotranspiration. So that's kind of my entry point. So yes, here we go, the next slide. So here's what we're gonna do for the next couple of hours, or I guess almost 2 hours. I'm gonna hope that most of you had a chance to attend the Introduction to Photogrammetry workshop, but I'm just gonna talk a little bit about it in case folks did not have that chance. And then compare Metashape and Pix4D a little bit. Pix4D is another tool that's commonly used for photogrammetry. Talk a little bit about hardware and hardware considerations for this type of processing work. And then there's several flavors of Metashape is how I kind of think about it. There's the graphic user interface. And if you, are coming into this is the place to start. Like, even if you eventually want to go to this scripting place, it's good to understand and think about the graphic user interface first. And then there's also some batch processing options within that GUI. So we're going to do a GUI demo and go through the graphic user interface for Metashape. And then I'm going to talk a little bit about just some scripting options that are available for Metashape. And then there is this parallel computing option. I'm not going to go too much into that, but I just want to talk about how that's something to be thinking about, depending on you know, how much data you're going to be collecting, how much processing you're going to want to do. That's just something to kind of have in the back of your head. And then, so Logan Ebert, a graduate student researcher in my group, is here, and he's going to be kind of manning the text or the chat a little bit, and the Q&A, and answering the questions that he can when they come up. But then we're also going to take a few breaks here and there, just for, you know, bio breaks as well as breaks for questions. Okay, so photogrammetry, I think was wonderfully talked about by Maggie Kelly. I think it was that yesterday? Yeah, it was yesterday. And but this is just a quick recap, is that this idea that we are going to collect images from several different angles and, you know, put these images together with a high overlap, and then create, you know, these orthomosaics. That's one key product that comes out of this photogrammetric processing. But the other product that's pretty cool that we're starting to learn a lot about is structure from motion, and taking 2D imagery and providing, you know, a 3D product, that point cloud type of product. So those are kind of the key products that come out of this photogrammetric processing. And the idea is we capture these images from several different angles with a very high overlap. So you've planned your mission, you know, this is where we are. This is how I think about all this. Like, so let's say you've gotten your pilot exam, you know, you've dealt with whatever institutional issues that you have to deal with to think about for flying your drones. You've done your site selection, you've planned your mission, you have these imagery goals, right? Like everyone who's here, I assume, has very different imagery goals. And that's why I wanted to share mine. My imagery goals are, you know, using multiband and thermal imaging to develop maps of crop evapotranspiration. So to be very clear, those are my imagery goals. Derek, who co-developed this workshop with me, he has very different imagery goals in that he is a forestry person, and his imagery goals were to create this type of point cloud imagery and the structure from motion, and basically come up with these 3-dimensional representations of forests. So you have your imagery goals, you've done your mission planning, you've collected your, you know, had a successful missions, you've cataloged your imagery, you've backed it up. So that kind of getting at what we just did in our workshop before. So you've saved your data, you've backed it up, and now here we are, and we're thinking about post-processing those data and doing this photogrammetry work. So after this is the, you know, additional spatial analyses. I'll talk a little bit about how to do this. You can do some of it in Metashape, though I wouldn't recommend doing a lot of that. And then any additional geostatistical analyses that you might want to do, some deep learning. In ag, that, you know, when we're thinking about precision agriculture, for those of us who are interested in that, some management zone identification. Those are the steps that come after this one. So Agisoft has this Metashape product. And these are just the reasons, and knowing that, like, I'm a little biased because we ended up making the decision to use Metashape. I think Pix4D is a great product too. It's where we started. The camera that we started using is called the Mallika Sense Ultim, and it was discussed in our hardware talks as this combined multispectral and thermal camera. It was released in 2019, and that was when we got our UAS system. So we have a DJI Matrice 210 RTK system, and it's coupled to this Mallika Sense Ultim camera. So when we did all of our mission planning and started having these successful missions and collecting data, one of the issues that you may want to think about that we hadn't thought about is, depending on how new your camera is, there may not be, that camera information may not be embedded already in the program that you're using. So we ran into that. We got that Ultim camera just a couple months after it was released, and it wasn't in any of the programs. So Metashape was kind of one of the quickest programs to kind of adopt the MicaSense camera, the Altum camera, into its programming and post-processing software. So that helped us make that decision. So that was, you know, an issue with Pix4D, is we weren't able to select our camera for post-processing. Both of them give you this option for radiometric calibration of your multispectral imagery. If you're using multispectral imagery, you know, you have the opportunity to make digital elevation models, digital surface models, orthomosaics, as well as point clouds in both of these programs. You can do this batch processing in Metashape, which is nice. And you can do Python scripting in both of the programs. But for Pix4D, you have to have the additional Pix4D engine engine software. And the cost of the programs is different for that. Metashape, in order to get to this Python scripting place, and even in general, is much cheaper than Pix4D, which is a big reason why we decided to go with Metashape, because Pix4D, I want to say the renewal licenses are, I think Metashape is about 1/10 of what it costs for Pix4D. So I want to talk about hardware a little bit here. Actually, I'm going to pause and have a look at what's happening in chats. And Logan, do you want to unmute yourself for a second? Did anybody have any kind of questions on the beginning stuff?
Mallika, I don't see anything.
Okay,
Really.
because folks can also raise your, I'll check periodically too if you want to raise your hand. I think the hand raising function's enabled too, right?
Yes.
Okay.
They just have to select participants, and then they'll have the various yes, no, raise hand.
Okay, cool. So feel free to use your hand raising function, put stuff in the chat. Yes, we can slow down and talk, because we've got the time to do so. So I think that to do this type of processing, if you're going to be doing a lot of it, it pays to invest in a GPU, because all of these programs, I think, at least both Pix4D and Metashape, have certain steps in their workflow that are accelerated if you use, you know, a GPU. And we call these GPU accelerated steps. So in Metashape, it's image matching, depth map reconstruction, you know, depth map based mesh, DEM and tiled model generation, and texture blending. So a lot of those steps, you'll just see a much greater increase in speed if you decide to invest in a GPU. But, you know, at the same time, if you just are going to be just doing these kind of small batch index calculations, Pix4D might be fine, or Metashape with no GPU might be fine. This is, like I was mentioning, we started using Pix4D and just using the GUI. And, you know, when you're just doing a few different flights every once in a while and you want to sit through and click through this GUI, then that's great. Like, this is just an example of some flights that we did in the Midwestern United States in Wisconsin. This field, it's a maize field corn, and we're looking at different indices that are related to nitrogen stress. A student who's working with me, Alex Chisholm, collected these data, and you know, this didn't take that much time to process, do all the photogrammetry in Pix4D one by one and generate the indices for each of the flights. But then this is kind of where we started going. And this is, I would say, kind of the blessing and the curse of being able to work with drones and collect these data, is it's relatively easy to amass a lot of data. But the processing that you need to do, you start to get to this place where it's like, oh, well, we're going to do 20 missions, or, you know, we're going to do 30 missions, and you have all of these missions, and, you know, you want to process all of them, and the processing time takes a long time, and you just, like anything else that you would automate for yourself, this is not necessarily something you want to sit through and click through. You might want to get to this place where you batch process or you script. So getting to the flavors of Metashape, we're going to take some time now, and I'm just going to like walk you through the graphic user interface. And I'm hopeful that most folks have had the chance to download the data. So that's what we're going to do right now. Sean and Logan, just feel free to interrupt me if you see questions in the chat window. How about we do it that way?
It works for me.
All right, sounds good. So then I'm going to open this up. Okay, so I have given you guys like this. Okay, so I'm going to stop my share for a moment. And hopefully everyone who wants to kind of participate in this part of the workshop has had the opportunity to download Metashape. So I'm going to share. I'm just going to share it all. I think we're going to share my desktop is the best way to do this. Okay. So welcome to my life. I'm just sharing my desktop. So here is, if you open up Metashape, here's kind of what it looks like in the very beginning. I had this step 0 for all of you before we get into going through and doing all of the steps involved in photogrammetry. And I'm going to take a moment and do step 0 with you, because as I mentioned, like my work is not in this, 3D reconstruction forestry, but my collaborator, Derek, who helped me put together this workshop, he does do that kind of work. And so he has provided all of us the opportunity to visit Lake Tahoe. So I think we should do that. So it's in your folder. It's this emerald point underscore DJN_young.psz. So this is a Metashape project file. So if you were, it's already been processed, so it's not going to take a ton of time. But as you noted, maybe it took a little time to even open it. So here is, this is a dense cloud that has already been processed, and it's from Emerald Bay State Park. And Dr. Derek Young collected these data, and this is just to give all of you I hope an inspiring look at what you can do with RGB data with very high overlap, and what like a processed product looks like. And I wanted to show this to you because you can pan around, and I think this is pretty cool because it's almost like you can observe different features and really see what this reconstruction looks like. And I actually think even this, in order to make this a smaller file, he's even kind of thinned out these data. I think his original data set was even higher resolution than this. But this is kind of, I just wanted to show, because the rest of the data that I'm going to show you are from ag. I thought it would be fun to play around in a forest and look at this 3D work. So I would recommend, I've provided you that file just so you can have a look and play around with that. So I'm gonna get rid of this. And the Metashape calls these, they call them chunks, or what you would use. That's just kind of Metashape language. So
we had a question of what the extent of that point cloud was.
What is the extent of this point cloud? Oh boy, I do not know. That is a great question. That is something, is there gonna be a way, Sean, to like share information after the fact with folks?
Information regarding the exercise, we can always put it on the website, on the
Okay. Yeah, just because I didn't collect the data, so I'm not sure what the exact extent of the point cloud is, but that's a great one. You know what I'm gonna do though? I think Derek has the same point cloud processed on his website. which is, I'm going to just direct everyone to check out his website too. And I told him, as I said, he couldn't be here, though he helped to develop this. Okay, everyone can see this browser, right? So let's see here, more details. This is the same, he's processed this in a different way here, but these are the same data. Emerald Point Lake Tahoe. He doesn't have any info on his site, but yeah, I will try to get that question answered from Derek and let you folks know, because that's a great question.
We could put it in the community forum as well if you like.
Yeah, that would be good. Okay, so so hopefully everyone's got this kind of GUI demo here. And I just took notes, so if you want to replicate this at another point, to go ahead and do it, just so you have all of the steps put together, and you don't have to just rely on this video at a later point. And once again, just talking through the data that are in here. So I collected, with Logan really piloted, and I was the visual observer. We collected this data, the data set, both the imagery subsection from the data and the whole data set, which I've included, but we're not going to work with just because look at the size here. And the processing time, like I mentioned, the processing time to do a workshop with a real data set would be not feasible. So we collected these data in September of 2019. They are from 2 cherry orchards, and they're located in Linden, California, in the US. So it was September 20th, between 1 to 1:26 p.m. Pacific time, and the height of the data, the data set, we collected it at 90 meters. We used, as I mentioned, a Mallika Sense Altum camera and a DJI 210 RTK drone. For those who are interested in ground measurements, like I said, I am interested in evapotranspiration. So for us, we are always curious to find and excited to collaborate with folks who are collecting ground-based measurements of evapotranspiration. So in this case, there's an eddy flux, there are 2 eddy flux towers, one in each orchard, installed by Dr. Kosana Suvachara at UC Davis. And the larger part of the experiment is to think about new irrigation requirements and decision support tools for California cherry growers. So you all now have some cherry data, cherry-picked cherry data, and that's what that subsection. So the subsection is just a few rows, 350 megabytes there, whereas the whole cherry orchard, this is just for your reference if you want to, once again, I just thought, for those who maybe haven't gotten drones yet, are still thinking, interested in ag, why not provide the whole data set to play around with? And also, it's another way to compare and to think about this image processing issue in the timing, right? Like if you want to test out your hardware, it's nice to do some benchmarking, which is something that you might want to think about on that hardware end when you're thinking about graphics cards and upgrading and things like that. For this particular camera, to do the reflectance or the radiometric calibration, there's a CSV file that's just the calibration file that's used with the calibration panel that Mallika Sense provides with, I think they provide these panels with all of their cameras to do radiometric calibrations. And Metashape will do that calibration for you. And we're gonna go through that calibration. So that's what this file is about. And then we already talked a little bit about this fun Emerald Point data to play with. So hopefully everyone's got this free 30-day trial of Agisoft Metashape. And everyone has it installed who's going to be following along with us. And then there's some information about how to do that. We already took our trip to Lake Tahoe. So we are going to open up Metashape. Actually I'm going to close it so I need a new chunk. So Metashape went well for me. Move some stuff. Here's Metashape. All right. So you're opening up Metashape, however that's going to be.
Mallika, we had a question about the preferred computer specs for processing using Metashape.
Yeah. So there is some information about that just on the download page about what is required. But kind of like I had mentioned about what is preferred, I think it gets at how much do you want to spend on a graphics card. Like, so I think if you are willing to add a graphics card to your computer, that could help. There is some benchmarking. There are some benchmarking studies out there that looked at different graphic cards, and I can see if I can find that. Agisoft Metashape, and just like put the link in the chat here. But you can use it on Mac, you can use it on Linux, and you can also use it on PCs. And that actually is something to mention. Benchmarking,
Mallika, if you'd like, I can look for it and put it in the chat.
Yeah, that would. I think I found it here. Systems. Yeah, so was it this one? That'd be great. I think that would be awesome. But if I would say Google, Google these things, Agisoft Metashape benchmarking GPU, because the question is that the question that you're going to want to ask yourself is how much speed do you want from your GPU in order to do your graphics processing and do your photogrammetry, right? So there's, at some point there's diminishing returns. We spent about, I think, $300 on an NVIDIA graphics card. And that really, that changed the game, that really greatly improved our processing. But I think looking at some of this benchmarking information that's out there, you get to this place where you're going to be spending hundreds of dollars to get maybe an additional 14% in terms of, or 15% in terms of your speed. So that's kind of, those are some of the questions you want to ask yourself as you get into this. So when this person double clicks the dense cloud, the model doesn't show up. Is there a loading indicator anywhere you cannot see? Okay, so that's an interesting question. Let's see here. So you're opening up the Emerald Point. There's this loading indicator. So did you see this, folks who are not seeing? So you double click the dense cloud. Okay, so the dense cloud showed up. Okay, so if you select chunk, double click dense cloud, and added dense cloud. Okay, and then I double clicked on the dense cloud. Let's see here. So in Metashape, there is this kind of loading project, finish processing in the console. You can kind of see what's going on a little bit in the console. And if you're actually doing processing, you'll see some action happening down here. But yeah, so folks who are not having it pop up, I'm not sure what to tell you. What happens when you double click on the dense? Yeah, thank you, Janet, or Jeanette. So maybe give it a few minutes and see what happens. Okay, well, we'll check back on that. but this is not, this dense cloud for this forest is not what we're gonna process right now. we're gonna do some other stuff. So I'm gonna remove that. Yes. Okay. So I know the forestry imagery is so much more beautiful than my cherry orchard, but I think the cherry orchard's really beautiful. Okay, so I'm gonna move on, and okay, so we are going to go, we're gonna go here to this part that's called GUI demo. So in your folder, there's something, it's called, okay, so there's an additional folder here, and it's called Metashape DroneCamp Orchard, Cherry Orchard subsection. And sorry, I had not renamed that. That needed to be renamed. So if you click in that folder, just have a look. Inside the folder, there's several different images, right? And every image has 1 through 6 in the TIFFs. And these are just the different bands in the Altum camera. So in bands 1 through 5 are the multispectral bands, and band 6 is the thermal band. So you should be able to go and just click on add folder. So it's in workflow. So there are all of these different menus here. Man, time is flying fast. Okay, so I'm gonna kind of focus on doing this. So if you go to workflow, there's add folder. So you'll wanna add the folder, navigate to where the folder is. So I've got it ready to go here. Okay, so we'll do open. And when you're adding the folders and this is, once again, I'm assuming that everyone is using the same camera system as me, which is a combined multi-band and thermal camera. So we're using an Altum. So this is a multi-camera system. So we would select multi-camera system. So right now, it would add all of the images to one chunk as separate cameras, and we don't want that. We want one camera system. So that's why it's saying adding 11 cameras, because we have these 6 different bands. So it'll take some time. And so it's adding these cameras. All right, so we're gonna go to our next step, and our next step is to calibrate. So we are going to go to tools. I need to move this. So we're out of the way. Tools. All right. Calibrate reflectance. So what was that? Okay. So first, to calibrate reflectance, if you are using a multiband or multispectral camera, you're going to want to locate these reflectance panels. And what it's doing now is it's going through and it's looking for the calibration images, because if you are using any of the MicaSense cameras, you are going to, oh, there it is, good. If you're using any of the MicaSense cameras and you are using this calibration panel for the radiometric calibration, you're gonna basically, before and after your flight, collect these calibration images. So I'm gonna just kind of show you, oh, I can't do it just yet. You can see it right here a little bit. This is a calibration image of what one of the panels looks, or what one of these panel images look like. So you just would take a few images before and after your flight. So, when you're in this processing phase, it's going to use the metadata and locate that panel. So we found the panel. I'm guessing that for everyone who's participating, you're not going to just see these numbers pop up. These numbers are popping up just because Metashape remembers that I have saved that CSV file, but you are going to want to hit select panel and then navigate to wherever you've got this CSV file, which is going to be, you know, in the Metashape workshop folder, wherever you have saved that. So you're going to want to navigate to that and select it. So I'll just add another panel just to kind of go through that process. So here it is. We add it, open her up, say okay. And then select one. They're all the same for me because I've kind of gone through this process a few times. So, and then you'll see all these numbers come up. So this is going to be for your reflectance calibration. So hit OK. And then depending on your camera, so for us, we want to use the sun sensor and the reflectance panels because we have those things on our camera. So you'll want to, you know, depending on what kind of a camera system you have for this processing, think through some of these issues. And for MicaSense cameras, if you have a MicaSense camera, they have documentation on how to do the calibration and many of the photogrammetry steps in Metashape. So we hit OK, and now it does that. So, I mean, once again, I have picked out a very, very small data set for this workshop, so it happened very quickly. But if you are using real, you know, a sizable data set from, you know, a regular size, a 160-acre agricultural field, that step is going to take a long time. So these steps actually are falling pretty closely to what Maggie discussed in her workshop about introduction to photogrammetry and just the sequence of events that we're doing. So this step is just going to use those estimated camera locations to align the photos. So we're going to basically go to workflow, and align photos. And once again, for our camera, we don't have to change anything, but you'll want to check to make sure that applies to the camera that you're using. So the step takes a little bit. I have a 2015 MacBook Pro for anyone who's curious about what I'm using right at this moment. I'm going to take a look at the chat. Okay, which parameter was selected? So for this, if you look at your document, the Metashape GUI demo plus questions, I've got just a screen grab of exactly what this should look like. So you'd want to select generic pre-selection and reference pre-selection. You don't need to change anything. This is the default setting for a MicaSense camera. And what should things look like when this step is done? Still going. Any other questions? So like I thought we'd do this live so we can kind of talk if there are any questions during these moments. Oh no, sorry, Cody. Everybody, there is a demo document. The demo document is in the Metashape workshop folder, and it is called Metashape _GUI _demo plus questions. Oh, Rosa's done. I need to get, yeah. I mean, I would expect that I'm gonna have one of the slower computers here, which is good, right? Like I didn't want to be done first. Where can you find information to determine what selections to make for your own camera? So once again, I would start, Rosa, she's like moving ahead on the GUI doc. That's cool if you want to move ahead on the GUI doc. I mean, ideally you should be able to kind of work through this on your own too. So determine hot GPU. Model display is still blank. Okay, so well, we'll get to that. So where can you find information to determine selections to make for your own camera? I would start by like going to Googling your camera name in Agisoft Metashape and seeing if there's any sort of, I guess Google basically, to see if there's any sort of documentation and whether that documentation is gonna come from Metashape or the camera company. Those are kind of the two groups that both have a stake in wanting you to successfully process your data. I believe for me, the documentation came from Mallika Sense, not Metashape. So I'm just gonna Google Mallika Sense, Altum, Metashape. Let's see. Yeah, processing work. Oh no, I was wrong. It came from Agisoft. So they also have a stake. But they both are kind of, there's two links here and they both will link you to it. And if you can't find it, you know, if it doesn't exist, I'm really kind of brazen about asking tech support for help or for support in answering some of these questions with the companies where you've, you know, presumably spent a lot of money to either purchase these cameras or to get licensing for the software. So I feel like it's totally all right to ask. Okay, so it looks like I am finished here. So you don't see much. So you want to select the tie points. Oh, get out of the chat. What happened here? All right, it is 10:56 Pacific time. We are going to take a break and come back in, because we wanted to actually take a break around this time anyway, so it works out okay. We're going to come back in about 6 or 7 minutes, and hopefully I'm going to run mine again and get us to a better place. And so that's what we'll do. So we'll be back. All right, well, it's 11:05, we're back. So everyone has an update. I think I probably was just chatting too much with all of you and hit some weird button or something because I just ran it again and everything seemed to work out. So I'm going to do what I said I would do and not look too much at the chat unless somebody reminds me to look at the chat. So, you know, here's kind of what your screen should look like after this step is complete. Here's what my screen looks like. If you go to the, and this is the model tab, if you go to the ortho tab, you'll see the photos, and this isn't that many photos, right? This is, it says 11 cameras. You can think of that as 11 photos taken during this flight. So the next step, so we've aligned the photos, it's kind of, and now we use the models to optimize this camera alignment. And Maggie, once again, gave a very detailed explanation of what this step actually means during her presentation. So this is how that looks in Metashape. So we would go back to the GUI and go into Tools, Optimize Cameras. So there's all of these fits. These are basically parameters for the model. And once again, I've got the parameters for my camera. And once that's another thing, just the first time you go through this, you're going to want to make sure you understand what the fits should be for your camera. So all of these boxes need to be checked for a Mallika Sense Altum. If there's anybody else who's got a Mallika Sense Altum, you're in luck, because this is, you can just kind of follow this almost exactly. Hit OK. This is going to take some time again too. Oh, not as much. Okay, so this is kind of a fun step, and this next step also takes a bit of time, which is we're going to build that dense cloud, right? So this is a great step. It's where the points and the camera locations from several 2D images, they're used, and we're going to make this 3D cloud of points and images. The reason that I wanted to provide Derek's data from Emerald Bay, the RGB data, is his RGB data is much higher resolution because he purchased a camera with intent to build that type of build point clouds and kind of do structure from motion and get his 3D structure from the 2D imagery, whereas we purchased our camera and do our flights in order to create ET maps or crop water use maps. So our cloud's not going to be quite as awesome as the other one that you saw. So, but we would go, it's in workflow again. And if we go to tool or workflow, build dense cloud, and we want it to be medium quality, aggressive. Okay, so this is something that annoys me in Metashape and is worth like mentioning, which is you can do calculate point colors, but I did a deep dive, a deep troubleshooting dive on this one day. And even though there is a red, a green, and a blue band in my multispectral imagery, Metashape will not assign colors to those bands in this step. So they'll only assign point colors and calculate point colors if you have RGB imagery. And what they told me when I was kind of troubleshooting and trying to figure this out is that if I stripped the other bands out of my imagery and just had the RG and B bands, then they would calculate point colors. But of course, I'm not going to do that. So it makes me a little bit grouchy, but here we are. But it's good to share like limitations. So this is something that bothered me a lot. And we did this deep dive and this is what we found. So sorry, no beautiful colors. That's another reason why you've got your Lake Tahoe scene. This is gonna take a little bit.
Mallika, we wanted someone to explain what depth filtering is.
Oh, in the, filtering. Honestly, I am not sure what it is. Is there anybody else who is more of an expert on each individual step who could comment to that?
I'm afraid that I don't know the terminology here in this.
Yeah, I'm not exactly sure what's happening in that step. And to be very frank with everyone, like I've done a deep dive on these settings when I haven't been able to figure them out or something weird has happened. And this is just one where it was suggested that I use this for my camera and I'm not super sure as to what this exactly means. So I cannot answer your question, but it is a good question. And that, I guess, is another point, right? With all of this work and with photogrammetry and with your processing is like, how much do you want to become an expert on processing and how much do you want to get your stuff processed? And for me, I want to have great data. I want to have good orthomosaics, but I am not somebody who's going to know every single step and exactly what's going on. It's just not my area of expertise. My area of expertise is still on that crop water side.
So Brandon Stark, who has a lot of experience with this application, notes that depth filtering adjusts how much filtering is done to the point clouds, and aggressive will remove the sharp edges while none will keep them in.
Thank you. Thanks, Brandon. Glad you're here. All right, so we are processed. So, but you don't see anything, right? Everything looks the same. You have to actually go in and click on it to see it. Here it is. So you can still zoom and you can still pan, and these cherry trees I think are still pretty cool, but it's not as, you know, the cloud itself is not going to have as much of that 3D structure as you saw when you were looking at the Tahoe data. But you can still pan in the same way and start to see. There's actually two cherry orchards here. There's an orchard right here and there's an orchard right here. And there's some subtle differences in them that we can talk about at the end. So, yep, you can pan around in the same way. And the next step would be, you know, for most of us, I think you want to build this digital elevation model. So same thing, you can go into workflow, and in the workflow, it actually, the order in which this is set up it's set up in such a way to kind of mirror the order that you'd actually go about doing some of this work. So so you're going to use the dense cloud, so that's the source data, to build the DEM. And I enable the interpolation. You can extrapolate to and create boundaries, but I don't have a need to do that, so I usually just interpolate. It'll automatically calculate the boundaries for you. And it has your resolution of what the resulting DEM is gonna look like that it's calculated for you. So hit OK. Oh, it forces you to save right now. That's good. So it forces you to save the project because it doesn't want you to lose everything that you've done. So yes, we will listen. We will save. So I will just write DroneCamp Metashape demo, and it's saving it as a Metashape project file. Okay. So it saved it, but now we have to go back and do that, right? So hopefully you will not be like me and you will save it prior to trying to do that. So we do the same thing. Everything is the same. We hit OK. Now it's going to generate this DEM. That felt fast. Yeah, that was just fast. It was fast because it's small. So if you want to look at the DEM, same thing. You go back into this chunk. Oh, yay. Here's the DEM. And it's in this ortho tab. So you can kind of look and see how that looks. You can pan around, same thing. Okay, so we also talked about this a little bit. What we have built is a digital surface model. So it includes the heights of the trees in the surface reconstruction. I'm not gonna go through and do this now, just in the interest of having some time, but I am gonna pause and show all of you, for those who are interested in like canopy height and these types of calculations. Oh, I'm at work. Okay. So if you go to
Mallika, one question someone has is, how accurate is this?
How accurate is the DEM? Yeah, and I mean, that I think is going to depend on like all of the spatial considerations that we talked about. That's going to depend on the accuracy of the GPS on the ground control points and everything that you've set up. Right now, we have an RTK system, but I do not think we actually had RTK set up while we were collecting this imagery. But the camera that we have has an additional, I think they call it, what do they call it? SLR card or something? They have an additional card that gets you to, I believe, the survey quality GPS. So not RTK GPS, but survey quality GPS. So I would think and guess that that is going to be, I wouldn't take this surface to be, I would say that this is an uncalibrated DEM at this point. But there are steps that you could take to calibrate it. Hopefully that answered that question. Okay. So I was going to show you.
Mallika, we had a question of when you'd want to build the DEM based off of a mesh rather than the dense cloud.
Oh, that's a good question. When would you want to build the DEM off of a mesh instead of a dense cloud? I haven't come across this a time when you'd want to do that. I usually am building it off of a dense cloud. Is there anybody who has built off of a mesh that wants to share or think through what that time would look like?
My understanding that you would just use the dense cloud because the mesh is inherently like built off of the dense cloud itself. So that would,
yeah, and I'm not sure why they kind of give you these options to do that, because even for me, like when I looked into it, we were thinking about like, oh well, we're not necessarily interested in the dense cloud itself, and doing this kind of 3D structure work. We really just want to get, for our work, we want to get to this orthomosaic. So, but we still, even in looking into that, we still wanted to build it from the dense cloud specifically. Okay, so I was going to show everyone, here, okay. is it tie points? So I wanted to kind of show everyone, it's gonna take me a minute to, here it is. Okay, so if you want to go and actually take the digital surface model right now, and you can go in and you can start to classify ground points. So and I'm not going to do all of this right now, but I just wanted to show people where it was if you wanted to do some of that work and get to making, you know, perhaps a map of canopy height. But you can go into tools, into dense cloud, and classify ground points. And, you know, you can start to, you know, think about vegetation and create layers within the data. So there are some of these more advanced tools and calculations that can be done here within the program. I'm just not gonna go through that today. I just wanted to point out that it exists. So we have this surface model, but you could do more analysis and more work, you know, to get at height, to do some of that additional classification if that's a part of the purpose that you're, or a part of your goals for this work. So next step, build an orthomosaic. So we've already talked about a little bit like what an orthomosaic is. I just have another link for a little bit more information, but this is, for us, this is really what we want to get to. So we are in, so once again, we're going to go back to that workflow, build orthomosaic, here it is. All right. Okay, so I don't think I've got to touch anything. Oh, I do. I have this disabled here. And that looks, you can estimate the size. Okay. This takes a little bit of time. Whoa, so Brandon, you think that we should maybe even be using meshes? Which makes it used to round a canopy. Besides what I'm doing with branches. Oh, interesting. Huh. Oh, that's kind of, oh, draping the skin over a skeleton. Okay, here's the ortho. All right, so it doesn't look, this is kind of getting to the not assigning the point colors part of it. So it looks just black. You can see a little bit there. So this is what your output's gonna look like, right? So you can do some index calculations here if you want to. And I'm just gonna show you a little bit of where to do that. Those index calculations are going to be this tool, this little palette tool right here. So you can go into this palette tool, and once again, you can see all of the bands in the camera. Metashape hasn't, basically for my thermal band here, right? So band 6 is this thermal band. It just hasn't really done anything with it. It just didn't include it in the calibration. It was just pretty much left alone. So you can do just some very basic calculations if you wanted to with these output bands. So I think I've got this is just to convert the values and how they're saved. So if I apply this, go to palette, you know, you can select NDVI. Once again, sometimes it's nice to just look, have a look here to see, you know, see what you've done, see what things look like. But I wouldn't recommend a lot of processing past this step in Metashape. There are other and better ways to do this type of processing and to you know, look at your indices. But it's nice sometimes to just have a look and see what you've got, or you know, if you want to look, for example, if we want to go back and look at the temperature data. I'm just going to check on the chat. Right. Oh, going too fast to enter. Oh, sorry. All right. Let me go back. So here are your output bands. And I'll just hang out here. Or actually, hey, let me put this in the chat. Chat. And this is just NDVI. Let me set up another band here. So you can hit this little plus and then have another opportunity. And so this is for temperature. The MicaSense Altum, the temperature is in centikelvins, and this is just to change that to Celsius. No, we're gonna have to change the color. So I just want everyone for the temperature to add this expression as the second band here. Okay, so for those who didn't change color, so after you do this, hit apply. So you'd hit apply. And for those who haven't seen the color change, you have to go into this palette portion. And when you go into the palette portion, make sure that you use band 1, select NDVI, and then there's this these arrows here to refresh or update. You're gonna wanna click update, and then then click auto to have it just scale, and then hit apply, and it should, hopefully, folks should see the color. Yes. So that's just kind of an NDVI estimate, and you can really see, you know, just even using this color scheme and using NDVI, you can see the trees, you can see the field road, there's some gaps. I think that's pretty neat. You can see that there's actually one of the things that's interesting about these two orchards is they have different planting densities, so you can observe that. The trees do look healthy. I agree. So that's a good question to kind of preview a little bit of what we're going to talk about with crop water stress tomorrow. Let's think about that tree health, right? So if you go to heat, which I know that this is not actually, the heat map isn't a very color friendly for those. So don't feel like you have to use the heat map. Actually, see, I could use, but if you do use heat, same thing, you could now go to band 2, because that's that temperature band. And then refresh, auto scale, and then hit apply. And here's a heat map. So you can kind of have a look and see what that temperature, those temperature data, so from that Altum temperature band. And the temperature band on the MicaSense Altum, it doesn't have as high of resolution as the multispectral bands. but you can still see there's relatively, you know, the field road is warmer. Plants that are using a lot of water and are healthier are going to have cooler temperatures. So in this densely planted orchard that is also has you know, using a lot of water at this particular moment that this image was collected, it's going to have cooler temperatures. There's kind of like there's this interesting gap right here. Maybe the plants on the right just got irrigated. Yeah, so it's interesting. The irrigation here is in this particular orchard, it's surface irrigation. It's drip irrigation, but on the surface. And I think you were right, actually. I think they were more recently irrigated than the other orchard. But I do think that they just also have, you know, they're using more water at this moment than the other orchard. And density matters. And we can see that the density we know that the density is different between these two orchards. This lower orchard that is using more water has a much higher planting density. So yeah, you can get some interesting information here. I think I'm gonna stop with the GUI, unless, is there anything? Oh, I do have on the Word document for folks who are interested in just exporting. I think that the export is pretty intuitive to figure out, but if you wanted to, you know, export your orthomosaics, there's some information. And then I have these like fun questions at the end, but we've already started to talk about, which is, you know, thinking about the planting. That I have, do you notice any differences? And I told you what the differences are. It's the planting density is different. You know, do any of the trees look stressed out? What do you think is between the rows of trees? I told you that too, unfortunately. Between the rows of trees, we've got a field road here. So, and then I actually kind of already mentioned that too. Which orchard do you think was using more water at this time, and why? And I think for the why, the reasons are, you know, the density issue, as well as thinking about when the irrigation last took place. So, okay, I'm going to stop sharing this for a moment. Were there any other questions before I kind of moved back to more? So oh, that's great. Well, I'm glad that you're excited. Hopefully we will get you even more excited. And then I'm hopeful too that it's been wonderful to have Brandon here, to have Sean here to answer some of these like very specific questions, but I'm hopeful that most of you, and I guess I'm hopeful that I am demonstrating, just get going, right? Try it out, troubleshoot as you need to troubleshoot, and kind of think through these issues as they apply to your camera, to your setup, to your outcomes. So, all right, I'm gonna go back into my slides.
Mallika, we had a question about where someone could find other types of cameras that plug into this program.
Yeah, I mean, theoretically, you should be able to use any type of camera with this program. It's just going to be going through and figuring out like what the settings are going to be for processing as you decide to go through and process your imagery. And I have not gone through the exercise of trying to figure out like, oh, what if I have a Zen Muse? How do I process it? But I'm sure that the information, Zen Muse, Metashape.
Mallika, a trick that I've used in setting templates for ArcGIS Pro is to load the camera into Pix4D and then look at the settings of the camera in there, and then record that, and then carry that over if you have access to another software. Some softwares have that built in, some don't.
Right, and that is great if I think one of the reasons why we ended up kind of going the direction that we did is Pix4D didn't have that option for us yet. I'm sure they do now. But depending on like when, when Pix4D decides to load your camera into it. But that makes a lot of sense too, because then you have all of the numbers and the specifics for it. But I'm just showing, I'm trying to find like an example for another camera. Can somebody share another camera that they'd maybe be interested in using? I was gonna look for ZenMuse just because it's another camera that's out there. Let's see here. ZenMuse X3, all right. X3, Metashape. So they've got it looks like that one might even just be in their general manual of how to set it up because it's such a commonly used.
The good news is once you figure out what your camera parameters are, you can save that and you're good to go for.
Yeah, like you do this one.
Yep.
Here we go. Okay, so I mean, there is going to basically be, you're just going to have to kind of do some Googling. I'm not finding like the same like beautiful link that I have for my camera to share. So they got, oh, here we go. Aerial data processing. Okay, I'm just gonna kind of send, they've got like a bunch of tutorials here. Send this, there we go. These are some tutorials, and I would say too, if you go to the Agisoft page and you don't see your camera, you have questions about like what a particular setting is, I have found that they are very responsive. They are in Russia, so the timing is a little weird when they respond. I mean, assuming that you're on Pacific time like me, you'll get like your response the next day typically. But they are very responsive in terms of exactly I mean, there have been times where I have sent them screen grabs of what I'm seeing, and they'll work with you to figure out exactly how to get it to work with your camera. So they are very responsive, and you should be able to either find stuff that's out there, you know, using different types of like message boards that are available, their help desk, or if you don't find something already out there for you, I would definitely encourage you to get in touch with them. Okay, so flavors of Metashape. Okay, so there is, oh, I didn't mention the batch processing that is available. I just want to show everyone where that is. Share screen, Metashape. Let's say it's in, batch process is under workflow. So there are, you can basically, I'm not going to go through and do this here, but you can, shoot. You can go through and create, you know, a step-by-step batch processing using, you know, different, you can basically set up different jobs and do it in this way. But I actually think that if you're at the point where you are setting up batches, you may as well kind of start thinking about scripting. So I'm going to stop that share and go back to sharing my screen, share PowerPoint, back into PowerPoint. Play from current slide. Okay, so I just wanted to share this resource. So this is the UC Davis Metashape Git page, and really a lot of the development for the Git, the tools, the Python tools for scripting Metashape have been primarily developed by Derek Young, and then we've been working in our group for, because he uses a different camera than we do, so for adapting the tools for the Altum camera. But really, once again, it kind of gets to setting it up that first time, or each step setting it up for your camera, and then you should be able to just kind of, you know, go from there. There is like a YAML file too, so you actually should be able to set up the tool, or set up some of these workflows without having to actually do a lot of coding in Python as well. But here's the GitHub page. I just wanted to, you know, show that to everybody, make it available. And then in coming months, if anybody is out there and has an Altum, we are working on automating our whole workflow with an Altum. So I would say, you know, if you're interested in using that with a specific camera, feel free to reach out to us, because it's something that we are working on as well. Because we want to move to a completely automated workflow over the next few months. Is we've kind of gotten to that place, like I mentioned, where we don't want to be using the GUI anymore. So, not sure if there's any. Okay. Oh, so this is an example here of just the YAML file that I'd mentioned. So it's basically, you can kind of take a look, and even to get to this place, right? Like, so to get to the place where you are wanting to automate this process, you're going to want to be pretty familiar with the GUI process for yourself and for your camera. So, you know, having done it enough times that you're comfortable with, you know, what are the different choices that you're going to have to make, because basically you're going to put those choices into this YAML file here, including, you know, your input path, your output path. And so, and then there's also just, I don't think I have this on this screen grab, but that you also are going to have to want to go in and select, right? Like all of the selections that we made and the menus that are in the GUI, you're going to want to build those selections into your automated process. And Metashape, there are tools to do that, and I would start with the UC Davis GitHub page for that. Okay, so this is just kind of an example of a command line call for how you would script, coming from Derek's forest structure data. Okay, so the other thing that you can do if you wanted to run several workflow batches in serial on a single computer is you can use a shell script. Once again, just kind of showing you what's possible here. So we talked a little bit about like graphics processing. There's also, you could take this to a place where you'd want to, depending on how much you're doing, and we are not in this place yet, but we're thinking about it, depending on how many missions you're running every year and how much data you're bringing in, you might want to think about parallel computing as well, and trying to take advantage of any cluster resources that are available. And so, the advantages of using a computing cluster is there's just going to be more CPUs per machine that you have access to. So you have all these, machines, many nodes. The this is just an example of the cluster that we have here at UC Davis. But if you are in an academic place, there's oftentimes going to be some sort of a cluster computing resource that's available to you. Once again, you should be, if you have these resources, this is just kind of looking at how it's done here at UC Davis, but there, you can, from the command line, run your processing in parallel. So this is many steps down the line, right? So step one, figure out the GUI. Get yourself comfortable with the GUI. Next step, try to figure out how to automate this process, right? Use Python, think about how you're gonna automate it, get automated. Step three, maybe think about, depending on how much data you have, do you want to use some sort of cluster computing? So I just wanted to bring up that those are kind of the considerations maybe to be making. So thank you so much. Oh, I also want to acknowledge Alex Mandel, who really helped us, both Derek and myself, a lot to kind of think through a lot of the work that we are doing right now with automating the process and getting to that place where we are no longer using that GUI. So helping us with our workflow. So he really did a lot of work with us to kind of think through and set up the GitHub site for UC Davis Metashape. So, all right, so those are my slides. We have some time left, and that's good. We have some time for discussion. I'm gonna stop my share.
Mallika, at some point, did you show them how to turn on the GPU in Metashape if you want to use it?
Logan, what a great idea. Yes, let's do that. Okay, so here is Metashape again. It is, I believe, you're gonna watch me try to find it. Oh, I have to share my screen again too. Okay, let me share my screen again. Get rid of that. So yeah, if anyone already is like a gamer, you can use your gaming graphics card in Metashape. And as I mentioned, the graphics card that we got for our, I don't do Metashape processing typically on this computer. We have a different computer for that purpose, where we have our graphics card installed. Okay, can everybody see Metashape again? Hopefully. All right.
Yes.
Yes, okay, good. So it's in preferences. So you'd go Metashape, preferences. So we're in preferences. And then you navigate to GPU. And then if you have, so you'll see actually whatever graphics card that you have just in your computer, if you don't have an external or separate graphics card dedicated for this. If you do, you'd want to select that, right? And that this is where you would select it. So that I'm not going to select it because this is just my internal graphics card and I don't want to use it. You only want to use it if you have a graphics card for this purpose. And you can also select use CPU when doing the GPU accelerated processing steps if you, for some reason, you didn't want to use your graphics processor for the acceleration. But this, if you have the external graphics card and you want to use it for, if you want to use it for those particular steps that I'd mentioned towards the beginning to have that acceleration, this is where you would go in and check. That was good. Good catch, Logan. Logan, do you have anything else you kind of want to mention?
No, not at the top of my head.
All right. That was good, though. Good catch.